Hey, welcome. So, machine learning, you hear this term everywhere, right? It's in your news feed, it's in your smart speaker, but what is it really? In this explainer, we're going to cut right through all the buzzwords and get to what this tech is all about. Let's do it.
All right, so let's just tackle the big question head on. When you hear machine learning, what pops into your head? For a lot of people, it's probably those sci-fi images of conscious robots or some super smart computer. The reality, though, is a little less Hollywood and a lot more, well, math. And that right there is the first big idea we need to wrap our heads around. This isn't about creating a machine that thinks or has feelings. Not at all. It's about using data to find patterns and make really good guesses. At its absolute core, machine learning is just a super powerful way to calculate the odds. To really get what's going on, we have got to look beyond the sci-fi hype. It's so important to see where these ideas actually came from because, the story is way older and much more down to earth than you might think. See, the dream of this stuff isn't new. The idea of, mechanizing thought, treating our rational thinking like a math problem, that goes back hundreds of years to philosophers like René Descartes. They had the vision, for sure, but they were missing two key things that we have tons of today: ridiculous amounts of computing power and even more ridiculous amounts of data. So if it's not thinking in the way we do, how in the world does a machine actually learn? Well, the most common way is by learning from examples, kind of like we do. And to really understand this, let's break down a tool you use every single day. Just think about your email spam filter for a second. Nobody programmed it with a giant list of every single possible spam message. That would be impossible. Instead, its algorithm was fed millions and millions of emails that we humans had already marked as spam or not spam. See, the algorithm isn't reading from meaning. It's just finding statistical patterns. It learns that emails with words like winner or free money or a bunch of exclamation points have a way higher probability of being spam. It's all about pattern recognition. And that word I just used, probability, that is everything. That's the key. At the end of the day, all of machine learning just boils down to this: calculating the chances of something happening based on what happened in the past. And it's always a number between 0, meaning impossible, and 1, meaning it's a sure thing. For example, what's the probability you'll draw an ace from a deck of cards? Simple, right? It's 4 out of 52. That's a basic calculation. A machine learning model is doing that exact same thing. Just instead of cards, it's calculating the odds that an email is spam or that a photo has a cat in it, based on thousands of different little details. Now, it turns out there isn't just one way for a machine to learn from all this data. There are actually 3 main strategies they use, and each one is good for a totally different kind of problem. Okay, so first up is supervised learning. This is our spam filter. We give the machine a bunch of data that's already labeled. This is spam, this isn't. It's like it gets to study with an answer key. Then you've got unsupervised learning. This is where you just dump a whole mess of data on the machine with no labels and basically say, go figure it out, find the patterns. This is the magic behind how Netflix recommends shows or Amazon suggests products. It figures out how to group you with other similar customers all by itself. And the third method is called reinforcement learning, which is all about learning from pure trial and error. Just imagine an algorithm trying to win a video game. It gets points for good moves and it gets penalized for bad ones. At first, it's just terrible, totally clumsy. But after playing millions of times, it can teach itself to be an absolute master, discovering strategies that no human would have ever even thought of. So we've got these different ways for machines to learn. That's cool. But not a single one of them works without one absolutely critical ingredient. It's not about the algorithm. It's about the fuel that makes the whole engine run. And that fuel is data. There's this old saying in computer science that is more true for machine learning than for anything else: garbage in, garbage out. It means that your model, no matter how brilliant it is completely at the mercy of the data you give it. And bad data can look like a lot of different things. You could have missing information that just confuses the algorithm. You could have outliers, these really weird one-off data points that completely throw off the math. Or you could have a ton of redundant information that makes it hard for the model to know what's actually important. Any one of these can lead to some seriously flawed results. And this is why the quality of our data is so important.
If the data we use to train a model reflects the biases that exist in the real world, well, then the model is going to learn and sometimes even amplify those exact same biases. It's not being evil, it's just a machine that's really good at finding the patterns it was shown. And that's how we can accidentally build systems that give us unfair or really skewed results.
This all leads us to our last and maybe our most important section. Look, machine learning is incredibly powerful, but it has some very real limits that we absolutely must understand.
One of the biggest limitations is this idea of a black swan. A black swan is an event that is so rare, so totally unexpected, that it's completely outside of anything the model has ever seen in its training data. And since these machines can only learn from the past, they get completely blindsided when the future looks nothing like what came before.
This is exactly why a model trained on decades of stock market data might totally miss a once-in-a-century financial crash. Or here's a simpler example. If you train a model to identify pictures of dogs and cats, and then you show it a picture of a raccoon, it has no idea what a raccoon is. It's going to try its best and probably guess it's a weird-looking dog or cat, because that's all it knows. It just can't handle the truly unexpected.
So here's the bottom line, the most crucial point of all. Machine learning is a tool. It's an amazing, powerful tool for finding patterns in data, but it's not an oracle. It doesn't have common sense or context or any kind of ethical judgment. We still need humans. We need people in the loop to ask the right questions, to make sure the data is fair, and to step in and handle those black swan events the machine just can't see coming. And that leaves us with one final thought to really chew on. In a lot of ways, these machine learning models are just a mirror. They reflect back to us the data we feed them, all of it. The good, the bad, the biases, everything. So the real question isn't just about what the machines are learning. It's about what our data is teaching them about us.